this video, I want to talk about the impulse component of the conservation of momentum when it comes to general planar motion and how we can look at that piece and apply the rotational terms in addition to the linear translation that we've covered before. So if we recall what we've seen before, which is that in linear momentum we have mv1 plus the integration over time of some force being applied in order to get to the momentum in state 2. And remember that this middle term is the impulse. So that's what's being added to our system in order to change the momentum, added to or subtracted from our system in order to change the momentum. So if we want to look at this in a rotational sense, so that we can put it all together, we can express again or start with the summation of moments as being equal to I alpha, and realizing that we can break alpha up into omega, change in omega over change in time, such that we can separate out those variables. We can rewrite this expression as the summation of moments multiplied by change in time is equal to Ig times change of velocity. So now we have terms here that we could go ahead and integrate both sides, and we end up with an expression that looks like this: Ig omega plus the integral over time of the moment So this, of course, looks very similar to what we saw above in the linear sense, where this middle term now represents angular impulse. And so we have that term. Now, really remembering that general planar motion is just the combination of translation and rotation happening at the same time, we can put all of this together, the linear momentum terms and this angular momentum equation, in order to represent the full state of what's going on in a general planar motion scenario. So writing it all out, all I've done here now is break apart my linear components into x and y, and we can do that recalling that these are all vector quantities, so we can break these up into Cartesian components if it is convenient for us to do so. And adding in what we just had, or just added to this, we get a set of equations that allows us to solve for problems in terms of the momentum before and after something occurs, and then the impulse of that external factor that's coming into play here, whether that's forces in the x or y directions or rotation. Now, of course, I'm only expressing this for the planar sense, and we could do the same sort of thing in a 3D model as well. But for many situations, if we can simplify using symmetry, this planar situation is sufficient for us, and we can make use of that. All right, thanks.